All right, for the majority of these, which is the more descriptive content, I'm just going to run through them all in one video. For the problems that require more work, I'm going to have those as separate videos that I'll link down below the main video. All right, so here for number one, so which of these substances is expected to have the highest boiling point? So none of these substances are polar, and none of these are capable of hydrogen bonding. In that case, whichever one is the heaviest will have the strongest intermolecular forces. If you look at your periodic table, I2 has the heaviest molar mass, so I2 will be the one that will have the strongest surface tension. It will be the hardest to melt, the hardest to boil, so it will have the highest boiling point. And we'll skip down here to number 3. In 3, it says the solubility of a solid always increases with increasing solvent temperature. The always is the problem for the true-false. It's almost always, it's usually, it's 99% of the time, but there are a few exceptions to this for solids dissolving into liquid solvents. So as far as always, that one is false. All right, I'll go a little above and beyond for number 4 here. We'll kind of talk about the whole diagram. So we've got A, B, and C. Point A there is the phase where it is a solid. I can tell that because this is the low temperature. And over here on the right side at the highest temperature, this is going to be the gas. That means we got 3 phases, solid, liquid, and gas, so the liquid is there in the middle. Also a couple of points on here. Where the 3 lines intersect, this is called the triple point. And areas where these lines just fall off, so this isn't a mistake, they didn't draw it short here. At this point right here, this is called a critical point. There, the substance is neither truly a liquid nor a gas. It's something like a really dense gas or a really thin liquid. So a super thin liquid, super thick gas, something like that. Imagine a really thick fog, something like that. All right, we'll go on to number 5 here. Which one is an example of a covalent network compound? I ask that you guys memorize or write it down since you'll have access to your materials when you do the exam. There are 3 of these that I want you to know. Covalent network solids are SiO2, silicon dioxide, that's sand, carbon in the graphite form, and then finally another one, which is carbon in the diamond form. And so for this question, SiO2. All right, the next one here, it says, which of the following species is dispersion the strongest? Anytime we're talking about dispersion, biggest better. So the biggest molecule here will have the most dispersion. This one right here in the middle, C, has 8 carbons. It's the most number of carbons, most number of hydrogens of all of these molecules. And so C there will have the most dispersion. We'll go to number 8. Which should exhibit hydrogen bonding in the liquid state. Hydrogen bonding. For hydrogen bonding to occur, we have to have hydrogen attached to an oxygen, or hydrogen attached to a nitrogen, or hydrogen attached to a fluorine. We have to have an OH, an NH, or an FH bond in the molecule. Well, none of these have an OH, an NF, so none of these first 4 have that, so the only one that is possible to exhibit hydrogen bonding is this guy. All right, so which of the following liquids would have the highest viscosity? Let's talk about intermolecular forces in general. So there's 3 types, H bonds, and those are much stronger than dipoles, which are stronger than dispersion. So if something's capable of hydrogen bonding, it's going to have higher than the others. So none of those are capable of hydrogen bonding, so it's down to either B or C. If you notice, B is capable of forming double the number of hydrogen bonds as C, so it will be that one. Since this has the strong intermolecular force, it will have a high viscosity. All right, another force that we've talked a little bit about, you've read about, is surface tension. And the interesting thing that happens here, so a razor blade is made from iron. The iron is denser than the water, but if you carefully lay a razor blade on top of the water, it will float until you take your finger and poke it below the surface, and that's due to the surface tension on the top of the water. All right, another read careful one. True or false, ethanol will have a greater viscosity than ethylene glycol. Well, ethylene glycol can form double the number of hydrogen bonds as ethanol, so we would expect ethylene glycol to have a higher viscosity than ethanol, not a lower one. This says ethanol greater than ethylene glycol, so that would be false. Which of the following crystallizes as a molecular solid? To be a molecular solid, it needs to be a molecular compound, and so it needs to be a combination of non-metal atoms that are connected together. So this has a metal, it's not that. That is a metal, that has a metal. This is our covalent network. That's one of the three I asked you guys to know, and so it's that one. 13 is a similar problem that we've seen before. Which one can form a covalent crystal? And that's silicon dioxide. All right, 14 now. Sodium iodide, NaI, melts at a high temperature. In its liquid state, it conducts electricity. You remember from Chem 111, ionic compounds are the ones that conduct electricity. Another example of a covalent network solid, diamond, carbon in the diamond form. You might be tricked from the previous one. So the solubility of gases in water always decreases. So the solubility decreases with increasing temperature. It ends up, for gases, that's true. For every single gas, if we increase the temperature of the liquid, then the gas becomes less soluble. So this isn't always, that is actually true. Again, you'll have your notes, so you'd want to compare your notes and carefully read these to select the right answer. A saturated solution contains, and it's A, the maximum amount of solute that will dissolve in that solvent. It cannot dissolve any more of the solid at all. And then finally, true or false, at a given temperature, CCl4 has a weaker surface tension than water. That is true because the water is capable of hydrogen bonding. The CCl4 is not capable of hydrogen bonding. Since water has stronger intermolecular forces, it has a higher surface tension than water.